our bell work up here. We've got, this first one says to graph 4y equals minus 8 plus, or sorry, minus 2x. It's still early. Coffee's still kicking in. And I forgot my stylus. Boop. Got it. So what can I do with this equation to make it be something we can graph? Because right now it's kind of icky. Yeah, if I divide everything by 4, that's going to make it so I can put this in slope-intercept form. But if I divide one thing by 4, so if I'm on this side of the equal sign and I divide by 4, I have to divide absolutely everything over here by that same number. So that gives us y equals negative 8 minus 4 is, or sorry, negative 8 divided by 4 is negative 2. And negative 2 divided by 4 is negative 1/2 x. That x is still there. We're going to leave him there. We need him there. Do not randomly drop x's for no reason. So how does dividing by 4 help us? Yeah, we're trying to get this to be y equals mx plus b. So I've got a y equals, what's my m? M is always with the x. Remember, it's mx every time. So my m is negative 1/2. What's my b? Negative 2. B does not have an x. B will never have an x. Negative 2. So mx, whatever's times the x, that's your m. It doesn't matter what order it's in. M is multiplied by the x. So where am I going to start when we're graphing this? Negative 2. Which negative 2? This one or that one or that one? On the y-axis. So this guy down here. Negative 2. How do I move? How do I find my next point? Down 1. Ooh. If I'm going down 1, do I also go left? Go right. Because normally we go rise over run. And if I need that to be negative, I can either flip the top and go right, or I can keep the top up and go left. Either one of these is negative. I only flip one. If I flip both, I'm back to positive. So we could go down 1, right 2, down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2, up 1, left 2. But you do need to find more points so you can connect them up. The more points you have, the easier it is to plot your line. My iPad doesn't like rulers. Yes, dear. What's up? Oh. This is literally the only thing we need rulers for today. Huzzah. Both ends get arrows. We draw to the edge of our graphs. Who sets it up? All right, questions on our line? Okay. So now we've got review from a whole chapter before. Our probability stuff. And I'm asking you 2 questions. I've got my probability of swirl and then the U, 6th grade, and my probability of strawberry and then the line, 7th. What does the U mean again? Very, very close. I'll take it. It's our union. But works. We got the vibe across. Union. Unity. Same deal. Who gets to come to the union? Who's involved in the union?
6th graders that like swirl.
All my 6th graders and all my people who like swirl ice cream. Everybody gets to come to the party. Unions are like weddings. Doesn't matter if you're on the swirl side, on the 6th grade side, everybody can come to the party. So this is where I need to take my everybody. So we're going to take all of my, sorry, I got my highlighters, 6th graders. How many 6th graders do we have? 350. How many people do we have that like swirl ice cream? 533. What are we going to do with those two numbers to combine them together? I want everybody in the same group. Add them together. But we have to watch out because did we count anybody twice?
Yes.
How many people did we count twice? 212. These guys were counted twice. So I need to take one set of them out, so I'm only counting them once. So this tells us the number of people who like swirl or the people who are in 6th grade. What's our total here? 671. So that's just my number of people. This is looking for a probability. So 671 out of how many? 900. Total. That one's, I think, one of the hardest of the probabilities is the union. All right. So now let's look at the bottom one. What does this line mean? It's not and. And's upside down U. If I know. I know. I know it. Which one do we know? Do we know 7th or do we know strawberry? 7th. Probability, strawberry, if I know 7th. That gives you a big old clue right there. If I know 7th. So I know they're in 7th grade. So I'm going to erase the other highlight marks because I'm going to use my highlighter again. I know they're in 7th grade. So I do not care about the 6th graders. I do not care about the 8th graders. I do not care about the totals. All I care about is 7th grade. So what is the probability that someone likes strawberry ice cream? 147 out of 300. So the line means if I know, and that's the only one that changes our denominator. It's been a hot minute since we saw those. Any questions? Or it's a hot minute since we talked through it. Okie dokie artichoke. So we are going to head into our next chapter, or module. That's weird. Using Canvas words. And this is going to be all about solving things. So we're going to have a significantly fewer number of graphs. Yay! Which means hopefully my confetti shame trash can will not get super full. That's just from yesterday. Which is not any of y'all, because y'all took a quiz yesterday, but still, I'm getting annoyed by the confetti. So, we're going to start with some vocab words to talk them through, and I'm actually going to add one in here for us to talk about as well. We're going to talk about equations, what a solution is, what it means to solve things, and I'm going to add in the word check. I just forget how nice my rug is because I stand off to the side, but I must put my little tray over here so it runs away. I stand properly on my rug because he's all squishy. I don't know. fit me way better. I'll stand over here anyway. That way I'm out of the way of the screen and I can still stand on the squishy. Alright. So equations we've seen before, lots and lots and lots of times. What makes an equation an equation? An equal sign. So our technical, like formal definition, I'm going to change my view so you don't have to zoom in so you can read my handwriting, is a mathematical statement that contains Lacio. Two expressions connected with an equal sign. So when we say mathematical expression, that's pretty much anything. 3 is a mathematical expression. 4x minus 2 is a mathematical expression. If I connect them with an equal sign, that turns this into an equation. Same thing if I have 2y minus 7, that's a mathematical expression. 7x squared plus 6, that's a mathematical expression. If I connect them, that makes an equation. We're not going to be working with squares right now, don't panic. I'm just trying to make fancy schmancy expressions. Okay, so two expressions connected by an equal sign. A single letter still counts as an expression. A single number still counts as an expression. So all it needs is an equal sign. What we're really going to be looking for in this chapter are solutions. And what a solution is, which can also be called a root, a zero, but not so much in this chapter. We're going to use zero. We're going to use mostly solution, root, x-intercept. Most of those are more for when we get into things that do have powers, but I like to always toss them out all at the same time because we sometimes struggle with that because it's 4 words that mean the same thing. So our solutions are a value that make an equation true. What's up? I sure did. A value that. That's what happens when I zoom in so that my handwriting's legible. I don't remember what words I've written. A value that makes an equation true. So for example, if we had something like 2x equals 6, what would x need to be to make that true? 2 times what is 6? 3. So 3 would be our solution. It's a statement that makes our equation true. And what we're going to be doing to find these solutions is we're going to be solving. So to solve is the process used to find a solution to an equation. Oop. when we are solving, there are lots of different orders in which things can be done. Sometimes that number of choices we have gets a little overwhelming. So if we struggle to find the starting point, I'm going to give you an option. I'm not saying this is the way you have to solve. This is an option for solving. Because we are very, very used to one particular phrase when we're remembering how to simplify stuff. We like to think of please, excuse, my dear Aunt Sally. Multiplication and division go together, addition and subtraction go together. When we simplify, meaning we're not crossing the equal sign, we go this way. This is for simplifying. Simplifying does not cross the equal sign. When we are solving, if we're not sure where to start from the outside and work your way in, which is almost always backwards up your PEMDAS. So go this way. Solve. Again, this is not your only option. There are lots of different pathways through. We're getting to the point in mathematics where you have a lot of creative choice in how you do it. But if finding that starting point is a place of struggle for you, this is a tool you can use to kind of help you figure out where to go. Because for some of us, the figuring out where to start is the hardest of everything. And that's okay. This is a thing that takes practice. Your brain is a muscle. And it's exercise. That's what this is. This is brain exercise. So this is me giving you a workout sheet. Okay? It's instead of me throwing you in the gym and say, all right, go. I'm giving you a list of things to do. So it's, again, not your only option, but it's a place to start. Okay? I was going to put the word check up on here as well, but I ran out of space. We are going to be solving equations, and we're going to check them. It's important that we use checks when we're solving to make sure, one, we've done things right, and two, we found a real answer. We're not going to have a lot of answers that aren't real in this chapter, but it will happen later in the year where we have problems that show up. So it's a good habit for us to be in. Sometimes I give you guys silly steps that feel silly right now, but I promise there's reasons. Okay, we're going to start with some simple ones. Remembering how to solve. We did something like this in the bell work already, but we're going to still remember. So our first one says x plus 4 equals 5. What can I do to solve this and find out what our solution would be? Minus 4 to both sides of my equal sign. So I'm going to actually draw a little wall right here. Solving is when we cross that equal sign. So if I'm going to subtract 4 from this side, I subtract 4 from this side. Make sure it's when we're crossing the equal sign that we're doing that. Because my solution here should be what? X equals 5 minus 4, which is 1. When we check things, because we are going to have to check stuff, we're going to go back to whatever our original equation was and substitute in our value. So we are checking to see if 1 plus 4 actually does equal 5. And we do this without crossing the equal sign. That helps us stop from making the same mistake twice. So we're just going to simplify this side now. 1 plus 4 indeed does equal 5. And 5 equals 5. So we checked it. So we're substituting it back in so that we can check. It's a way to double check what's going on. And I know on these ones it feels a little bit silly, because we can seriously do these. But we're going to do it because it's a good habit to be in. All right, looking at the second one, what are we going to do here? Add 3 to both sides of the equal sign. Plus 3. So my solution is x equals 8. Again, we're going to check it. We want to know if 8 minus 3 really does equal 5. And so we do this again, simplifying this side now. We don't cross the equal sign on a check. We simplify. We should only have numbers at that point. So 8 minus 3 is indeed 5, which does equal 5. So we checked it. We're good there. The check doesn't have to be a super long process. For the most part, with a check, we're going to type it in the calculator. But it's important that we think about it, and so I'm going to write it down for quite a while. All right, next one. What do we do here? What? Division, yeah. We need to divide both sides. What are we going to divide both sides by? By 2. If I divide by 2, this 2 and that 2 cancel out. So my x equals what? 2. 4 divided by 2. The only thing left on the left-hand side is my x. 4 divided by 2 is 2. Again, we're going to check this. 2 times, whenever I substitute in numbers with multiplication, I'm almost always going to put them in parentheses like this. It just helps us keep organized, especially when we wind up with negative numbers, to make sure that we're multiplying and not subtracting. So especially when we work with negative numbers, substituting in parentheses is going to be a super duper helpful skill. Again, on our check, we are not going to cross the equal sign. We're just going to combine our like terms here, or simplify. 2 times 2 is indeed 4, which does in fact equal 4, so we checked. In the instructions for homeworks and things, it will say solve and check. On the test, it'll say solve and check. So yes, you have to check. All right, the last of these kind of single steppers. What are we going to do on this bottom one to figure out what our solution is going to be? Multiply both sides by that denominator, by 2. The multiplication and the division cancel out, just like our multiplication and division canceled out here. Multiply by your denominator. Whenever you have a fraction, and if you don't want to deal with a fraction, multiply everybody by your denominator, and you can get rid of it. Like, it will cancel out. So what is my solution on this one? What does my x equal? 14. 7 times 2. Again, we're going to go through and check this. So I'm going to substitute my 14 in place of that x. And we want to know if 14 over 2 does in fact equal 7. What is 14 divided by 2? 7, which does in fact equal 7, so we checked it. So my solution here is 14. This just shows that we checked. My solution here was 2. My solution here was 8. My solution here was 1. Questions on any of these ones? Because they're just going to get bigger as we go throughout the day. So if we have questions on this one, ask it now. Because that's okay. All right, here's the next couple. They're a little bit bigger. We've got a 2-step equation and a 3-step equation. And these ones give you a lot of different options to go through it. Like, you could absolutely, I can see 2 or 3 different ways to go through this one right now. When you guys look at this first one over here, what is your instinct if I was to say solve? Distribute. Let's do it. That is an absolutely valid option. Let's distribute our 3 into our parentheses. You don't have to do it this way. 100% valid option to do it other with different directions. But if we distribute, that gets rid of our parentheses. So we're going to have 3 times x, which is just 3x, minus 3 times 2, which is 6. So all we did was simplify the left-hand side. We did not start any solving steps here. That was a simplifying step. So if I'm trying to figure out what x is going to be, what should I do next? Plus 6 on both sides. My 6 is being subtracted, so I need to do the opposite operation to get it to leave. So we're going to add 6 on this side of the equation. Remember, this is where we're crossing. So we add 6 over here. Crossing the equal sign. So I'm going to have my 3x is all that's left over here because my 6 and my negative 6 canceled out. So we have 3x equals what? (21). 15 plus 6. Which is absolutely 100% something you can type in the calculator. 15 plus 6, totally fine. What do we do next? How do I figure out what x is? Divide by 3 on both sides. I want x all by itself. A solution will always be your letter all by itself. X equals, y equals, z equals, r equals, q equals. It could be whatever letter we want. But we need that letter all by itself. So when I divide my 3x by 3, the 3's cancel out, and we're left with x equals what? What is 21 divided by 3? 7. So this is the solution we found, but we still need to check it. So I'm going to take my original equation, my 3 times this quantity of x, which is 7, minus 2, and we want to know if that equals 15. On our check, we are simplifying PEMDAS top to bottom. So we do our parentheses first. What is 7 minus 2? 5. So we have 3 times 5, which is 15, which does in fact equal 15, so we've checked it. Good for us, go team. Our answer is 7, but we have to check it. So that one had more pieces. Questions on anything there on where it came from? Okay. Let's do the right one. What's your instinct here? Because if we go the same way we did on the last one, you're going to get some fractiony stuff, and that's gross. Ew. So I mentioned it before when we talked about fractions. We see a fraction and we don't like it. We say, oh, whoa, what can I do to get rid of a fraction? Multiply by my denominator. So I need to multiply both sides of my equation by my denominator. So I'm going to multiply by 2 to both sides. When I multiply by 2 on the left-hand side, my 1/2 and my 2 cancels out, so I do not take it inside the parenthesis. It canceled out outside. Since it's in a quantity, we don't have to bring it in. So we need to be super careful on order of operations and when we do this, because if there wasn't parentheses, I would need to multiply every piece individually. But since it's in that parentheses, we don't have to worry about it. So all we're left with right now is my 5x plus 4. And we want to know when that equals 12 times 2, which is what? 24. And 100%, no shade in the calculator game. Use them. They are tools at our disposal. So this looks less gross already. No fractions. Huzzah. What should we do next? Let's subtract the 4. When in doubt, start at the bottom of our PEMDAS, adding and subtracting. So if I subtract 4 from over here, because I want to collect all my numbers on one side and all my letters on the other. Minus 4 from both sides. Just trying to get my numbers on one side and my letters on the other. So we're going to be left with our 5x here because my minus 4 and my plus 4 canceled out. 5x is going to equal 20. What do we do to figure out what x is? Divide by 5. My 5's cancel out, and we're left with x equals what? 4. So that's the solution we have. We still got to go back and check it. It's a great way to make sure that nothing went sideways. So I'm going to take my original equation, my 1/2 times the quantity 5 times my x, which was 4, plus 4 equals 12. And we're going to simplify. Now we're not crossing equal signs. We're simplifying our inside the parentheses first. So when we simplify inside our parentheses, what are we going to get? What is 5 times 4? 20. What is 20 plus 4? So we have 1/2 times 24. What is 1/2 times 24? Half of 24 is 12. When in doubt, type it in the calculator. That second column, third button down, our fraction button, you can put 1/2, hit the right arrow, parenthesis, 24. 1/2 times 24. So this one does check. Okay, so these ones are a little bit bigger. Questions on these? We're going to give you one even bigger. One more. Even bigger. Because sometimes they're going to start to look real gross. Ooh. We'll have this one be the last one for today. Okay, we want to figure out what x equals. I want to solve for x. Trying to get x by itself. And we see this and we go, ew, gross. Mostly because it has fractions. How do I get rid of a fraction? Multiply by my denominator. My equal sign is all the way over here. So I need to multiply this side by my denominator and this side by my denominator. So if you think about it this way, I'm multiplying this whole side by 3. And I'm multiplying this side by 3. Since there is a plus in the middle, I'm going to multiply both of these fractions. So I'm going to write this whole thing one more time. I'm going to have 3 times my 1/3, this dude, 2x minus 57, and 3 times my 1/3 x minus 6. And we want to know when that equals -4 times 3. What is -4 times 3? Negative what? 12. The reason I wrote it like that is so we remember that we're multiplying the whole side. This addition in the middle is what makes me multiply two different things. Now I have that my 3's cancel out here and my 3's cancel out here. So all I'm left with is 1 times 2x minus 57. Does that 1 actually do anything? So are my parentheses doing any jobs anymore? Or have we dealt with that? We've dealt with that. So we do not need to have our parentheses once nothing is being multiplied outside. So we have our 2x minus 57 plus, how about for this guy? Are my parentheses doing anything anymore? Nope, so we can just bring that down too. X minus 6 equals -12. You do not have to write this step out. I was just trying to get us a really good visual of what was happening here. So now we're ready to combine some like terms. If we're not crossing the equal sign, we're just going to combine our like terms. What do we have over here? 3x, 63, equals negative 12. If they're on the same side of the equal sign, we're just combining them together. It doesn't change the sign. I'm not adding 6 to the negative 57. It is negative 57 minus 6. What do we do next? Add 63. Add 63 to this side. Add 63 to this side. So I have 3x equals what? So my negative 12 plus 63 gave us 51. Again, use the calculators, feel free. What do we do for our last step here? Last step. Divide by 3 on both sides. So we're going to have our x equals what? 17. Okay? We have like a minute to the announcement bell, so check that by typing it in the calculator. Okay, less than a minute, but still. All right, it does check. It's important that we check. I'm going to pass out the first homework of the chapter. Oh my God. Yay. You guys can do everything on it. We are going to practice more with these things tomorrow, but you could do this whole thing. But I always make sure to give you guys 2 days on things, so it's going to be Friday because I don't like to do the let's do tomorrow thing. I'm still getting time. Thanks. As a math teacher, I was so much better at counting when I think that's how papers, but that is not always happen. Alright, I'm going to toss the announcement page up for all of a hot second before I go and pull up the school announcements. Boop, just so that we have it. Module 2 Homework 1 worksheet is going to be due on Friday. Even I already have it up here due Friday. I am going to get you another one before the end of this week that's due back on Monday. So we're going to have 2 homeworks from this chapter this week.